Hello, in this video we have this exponential equation. We have 2 to the power of k minus 2 to the power of L, and this equals 2016. So we are going to look for the value of k and the value of L that will satisfy this equation. Now if you look at this equation we have here, this number here 2016 is a positive number. So this actually means that 2016 is greater than 0. So if 2016 is greater than 0, that also means that 2 to the power of k is greater than 2 to the power of L. And this also translates to the fact that k is greater than L. So if k is greater than L, we will find a way of making k equals L. And one of the ways of doing that is by adding a constant, maybe c. So k equals L plus c. Or we can have it L equals k minus c. So these are the ways of making k or L to be equal to each other. So after doing this, the next thing is we can as well consider this one. So let's work with this. The next thing we are going to do is to replace this k here with L plus c. So the new equation, we are going to have something like 2 to the power of, instead of k here, we are going to have L plus c, and we have minus 2 to the power of L, and this equals 2016. So this will become our new equation. So let's go ahead and work with that. So I'll copy it down here. We have 2 to the power of L plus c, then we have minus 2 to the power of L. This equals 2016. Now let's consider this identity. If you have a to the power of n plus m, this equals a to the power of n times a to the power of m. So if we apply this identity right here, we are going to have 2 to the power of L times 2 to the power of c minus 2 to the power of L, and this equals 2016. So the next thing we are going to do is we have 2 power L here and we have 2 power L here. So let's factor that out. We are going to have 2 power L into, if you divide this by 2 power L, you are going to have 2 power c minus, if you divide this by 2 power L, you are going to have 1, and this equals 2016. So what do we do? 2 power L here, this will actually give us an even number. 2 power any number here will give us an even number. So 2 power L will give us an even number. So we can have here even. This is 2 power c. 2 power c here will give us an even number, but once you subtract 1 from it, that means we are going to have odd. The whole of this will give us odd. So we have even times odd. Now that means we need to split this 2016 into 2 parts. We are going to have even and we are going to have odd. So what we are going to do is we can have the two numbers that if you multiply, we are going to have 2016 is simply if you have 32 times 63. 32 here is even and 63 here is odd. So that means we are going to have 2 power L into 2 power c minus 1 equals 32 times 63. Now we can as well express this 32 in exponential form such as this. That means, remember, 2 to the power of 5 equals 32. That is 2 into 5 places. So that means we are going to have 2 power L into 2 power C minus 1 equals 2 power 5 times 63. So because of that, going back to what we had here, even times odd and even times odd, we are going to compare even to even and we are going to compare odd to odd. Remember, this even, this odd, and this is even, and this is odd. So let's go ahead and compare even to even. That means we are going to have 2 power L equals 2 power 5. And let's also compare odd to odd. We are going to have 2 power C minus 1 equals 63. So if we have this first equation here, if you have a power n equals a power m, that means you are going to have n equals m. Because the bases are the same, you compare the exponents. So here the bases are the same, we are going to compare the exponent. That means our L equals 5. Now let's solve this and find the value of C. We are going to have 2 power C equals 63 plus 1. We have taken this over to this part of this equation. We have 2 power C equals 63 plus 1 is 64. So we can go ahead and express this in terms of 2. So we are going to have 2 power C equals 2 to the power of 6. That is 64. So by doing that, we make use of this other identity as well. When the bases are the same, you compare the exponents. So from here we have C equals 6. So we have two solutions right now. Let me write it here. First is we have L equals 5, what we got here. Then second is we have C equals 6. Now we need to solve for K. Now let's get back to the equation that linked L and K, remember. So this is it. We made use of this particular equation, K equals L plus C. So let's recopy it. So I'm going to get back here. I have recall K equals L plus C. That means C is 6 and L is 5. We are going to have K equals L is 5 plus C is 6. And we have K equals 5 plus 6 is 11. So we have gotten all the values. We have gotten values for K, which is 11. And we have gotten value for L, which is what? 6. Now the next thing we are going to do is we can as well check if what we have done is correct. So let me have here check. How do you check? Recall the problem. 2 power K minus 2 power L equals 2016. And K is 11. We have 2 power 11 minus 2 power L is what? 6, right? Okay, L is 5. That is correct. L is 5. We have equals 2016. What is 2 power 11? Remember, 2 power 10 equals 1024. So 2 power 11 will be 1024 times 2. Which is equal to, or which equals, you multiply this 2 times 4, you have 8. 2 times 2, you have 4. 2 times 0, you have 0. 2 times 1, you have 2. 2048. So 2 power 11 is 2048. So we are going to have 2048 minus 2 power 5 is 32. And this equals 2016. Let's find out. 2048 minus 32, if you subtract 8 minus 2, you have 6. So you have 4 minus 3, you have 1. Then you have 20 here. You have 2016 equals 2016. So that means the two solutions here for K and L are absolutely correct. So that's it for the video. Thank you and goodbye.